This video, we're going to discuss the multiplicity of real zeros or real roots. We're going to look at things in factored form first, and then decide what the zero is that makes each factor equal to zero, and then look at the exponent on that factor to decide its multiplicity. Then we're going to talk about if it's an odd multiplicity, that it will cross through the x-axis at that x-intercept, and if it's an even multiplicity, it's going to touch but not cross through the x-axis at that x-intercept. So in this first problem here, we have zeros of x equals -5. Its multiplicity is going to be 1. And because that's an odd multiplicity, it's going to cross the x-axis there. And we have a 0 at x equals 5 that has a multiplicity of 4. And it is going to touch there since that's an even multiplicity. And the next one here, x equals 7, has a multiplicity of 1, which is odd, and it's going to cross. And then x equals -2 has a multiplicity of 3, which is odd, so it's also going to cross there. X squared plus 4 is an irreducible quadratic. It has only complex roots. You may not know what a complex number is, but it's what happens when we take the square root of -1. If we tried to set that equal to 0 and solve it, we would get x squared equals -4, and you can't find any number that you square and get a negative number. That's why that one's not factored down anymore. So it's not going to give us any x-intercepts. The only x-intercepts or zeros that we're going to get are from the factor x plus 5 quantity squared. So x is going to be equal to -5 with a multiplicity of 2. That's an even multiplicity, so it's going to touch. We have a 0 of x equals -1/3 for our first factor that has a multiplicity of 2. So it's going to touch there. And x equals -6 for our second factor that has a multiplicity of 3. And that's an odd multiplicity, so it's going to cross. We have a 0 at x equals -1/4. The multiplicity of 2. That's an even multiplicity, so it's going to touch. X squared plus 4 again is not going to break down anymore, so I don't worry about finding any zeros from that. Watch out for this x out front. That gives us a multiplicity of 1 on the 0, x is equal to 0. That's an odd multiplicity, so it's going to cross through. We have x squared minus 3 now equal to 0. And while that doesn't break down into any fractions, I can solve that x squared equals 3, x equals plus or minus √3. So we have x equals positive square root of 3 with a multiplicity of 1, and it's going to cross there. And x equals a negative square root of 3 with a multiplicity of 1, and it's going to cross there. If everything factors completely, all my multiplicities will add up to be my degree of my polynomial. Sometimes I have these quadratics that can't factor, but 3 times 2 is 6, plus another 2 here is 8. This would have been an 8th degree polynomial. Let's go ahead and find out now that x equals 0 is a 0 from this x to the 4th. That's a multiplicity of 4, which is an even multiplicity, so it's going to touch. the x-axis there. X squared minus 3, again, we've already calculated that, so I won't do that again for you. Multiplicity 1 for each of these, which is going to be crossing. For that odd multiplicity. No x's on the outside this time. This x squared plus 7 is an irreducible quadratic with complex solutions. This x squared plus 2 is an irreducible quadratic with complex solutions, so there's no real zeros for this. Let me just say there's no x-intercepts, since that's what it's asking about. Okay. And yeah. Then on this last one for this video, x equals 0, the multiplicity of 2. Since that's an even multiplicity, it's going to touch. X squared minus 5 is going to break down into x equals a positive square root of 5 or a negative square root of 5. Each of those has a multiplicity of 1. Which means that it's going to cross there. And we have x equals negative 7 with a multiplicity of 1, which is an odd multiplicity, so it's going to cross there. We'll come back next time and we'll analyze polynomial graphs. We're going to do all these things for our problems. So we'll see you in our next video.